In this demonstration, we're going to use integration methods to derive the formula for the volume of a cone. Now, all you've got to remember in relation to integration and volume is that volume, particularly of cones and spheres, are generated by rotating an area about an axis. So you're free to rotate about the x-axis or the y-axis, whichever you find easier to do. In order to generate a cone by rotation, we have to take a line which runs from the origin out perhaps to a point between the x and the y-axis, and all we've got to do is rotate that particular line around the x-axis. And if we do that, we'll end up with a cone. This particular line has to have an equation, and in order to have this equation here, remembering that it is a line that's going to form a cone, we need to relate this line to what the radius of the cone will be and the height of the cone. So if we take a look at this diagram here, we'll notice first of all that the height of the cone will be the same as the number of units along the x-axis from this point here to the origin, and the radius of the cone will simply be the same as the height of this line above the x-axis. Notice we get a right angle triangle. So therefore, in order to make sure that the triangle is linked to both height and radius of the cone that we're trying to form, the distance from the origin to this point will be known as the height, and the distance from that point up here to the end of the line will be known as r. So if we are h units along the x-axis and we're r units from the x-axis upwards and parallel to the y-axis, then this point here is obviously the point hr. Now what we have to do in the first part of the exercise is to get an equation for this line here, preferably in terms of h and r, because they are the two terms that we want to have in the equation representing the volume of this particular cone. So if we take the line, remember that in order to get the equation of a line, you always need three pieces of information. You need a point, you need a slope, and you need the formula. Now two things we already have. We have a point and we have a formula. The point has to be on the line, so we've got a choice. We can use the origin 0, 0 or HR. To make things easy, we're going to take 0, 0. And the slope of this red line here, we use the formula that we learned for junior cert, y2 minus y1 over x2 minus x1. And we simply use the 2 points that are on the line, namely the origin and HR. So y2 minus y1 becomes r minus 0, which is r, over x2 minus x1, which is h. So r over h represents the slope of that particular